Hello students, in this second video on the chapter data structure part 2 we are going to discuss some applications of the stack. In the previous video we have learned about how can we create the stack in the Python using the list data type. We have also learned how can we implement the push and pull and the peek operations on the stack using a list. Now the first application of the stack is that we can using the stack reverse a string or a line. For example, we have a string India is. Now what we can do is that we can push each and every character of the string one by one in a stack implemented with the in a stack implemented with the list. Suppose then what will happen, I will it every index I will push the elements into the stack and top will finally reach one by one at the last element where all the characters of the stack will be pushed. Now if I do the reverse process, that if I pop the each and every element of the stack, top will finally again will become the -1 and the stack will become empty, but during these elements are the reversed and we will be able to get a reverse string of that particular string. So in this way you can get a reverse string of the any string or a line. This can be shown in your book also. For example, there is a string and the characters are inserted. First we will do the operation of push S, then T, then A, then C, and then K. Then again we will remove the element. First K will be removed, then C, then A, then T, and then finally S. So we will get the reverse of the stack word using the stack. Second application of string is that we can generate strings. First, the Polish strings. According to the Polish mathematician, there are two more methods of writing any arithmetic expressions having binary operator and the operands. For example, we can write a plus b arithmetic expression in two more ways. Let us understand what are these two more ways. These two more ways are known as prefix and postfix notations. Let us try to understand these two notations one by one. According to the Polish notation, every mathematical expressions can be written in the following three forms: infix, prefix, and postfix. In the infix mathematical expression, the binary operator is always between the operands. See, a plus b, in the a and b are the operands and the plus is the operator. This method of writing an expression is a common and we all are using it for a long time. This is the method of writing is also followed in your mathematics. Now beside this there are two more methods of writing this in mathematics. For example, I can write this a plus b mathematical expression as plus ab in the prefix forms. In this the operator will come before the operands. Okay, and the third one method of writing the notation, third notation of writing an expression is postfix, which means that the operator will come after the binary operand. A binary operator will come after the operands. This is ab plus, in this case is the postfix notation of a plus b. Here the plus operator is used. A plus operator is kept after the operands a and b. Now this is the common method but not commonly used, but used in computing field. This is also used in computer field. Similarly, here are some examples of expressions which are converted in prefix and postfix form using the method of infix, prefix, and postfix. For example, a plus b star c is converted into the prefix form as follows. Now, while converting any prefix and postfix, the precedence of the operators is also taken into consideration when we have two or more operators are in there in a string. In this, b star c will be first evaluated, so it is star bc, it is converted, and then it is added to a, so a plus a will be added after the product of b and c. So b star c is the first there, and then we write the plus a. Similarly, in the bracket you know that the priority is changed. A minus c will be conducted first, so here a minus c we will write first, and then this subtraction a result of this subtraction will be multiplied by the b, so we have written star minus a plus b. Okay, I will show you these things how can we do one by one. For example, I can show you how can we write the prefix of this. Here I am showing you how can you write the this thing. See, the prefix notation is created in this way of this one. First I have created the prefix of this is plus ab, then I have created the prefix of this is the minus cd. Now these two are divided, so division will come before. These two are operands for the division, so this first operand will come after the division, and the second operand is minus cd, so this will come after. Okay, so this is the prefix. Again, see here how we have get the prefix of a plus b star c. A plus b star c prefix is calculated as follows. First we have converted this into prefix star bc, and then the result of this added it to a. So a will be the operand for this operator for this, it will come first, then the first operand a, and the second operand is this whole, so this whole has come. Similarly, you can see this prefix, how this prefix is converted. You can easily see how this prefix is changed. In this, a minus b is the first operand, minus ac is the first operand, then it is multiplied with the b, so b is star will be there, minus ac into b. Similarly, postfix of all these are also calculated, are also written. For example, a plus b star c. Now here we see that b star c will be first, so it is b star s. Okay, similarly we can write the postfix of all these functions. Okay, I hope you have understood the postfix and prefix of all these. There are certain examples which are given in your book also. Try to understand these examples, try to do these conversions, and to understand the how can we do the postfix and prefix. It is must necessary that you try to learn this conversions manually without using the stack, so that you will be able to use later on using stack you will be converting. Okay, so these are the few examples given in your book that you should do. Okay, there are certain C examples. Now this operation can be performed on the logical operators also. For example, not a or not b not c. The evaluation of, first you will consider what will be the evaluation of this not a or not b, and here because there is no operator we will consider and operator, and not c, this not c. Now you know that the all the not operators will be first evaluated and they are written first, so not a and not b and not c are already in the prefix form. Now in between and or, and has a high priority, so you first convert it into the postfix. What will happen in the postfix? B naught, see a naught, b naught and c naught. First a naught is, this is converted into postfix, this not b is converted into b naught, c naught c is converted into c naught, then b naught c naught and operator is converted, then or is there, or is converted with a naught b naught c naught and or. So in this way you can have converted, this is the final postfix expression of the all this thing. I hope you have understood this thing. Now I am moving to the algorithm for the conversion of infix to prefix. Converting of infix to prefix conversion. Before doing this algorithm, you have to keep in mind about the that the operators have a precedence rule, and the exponential operator has the highest precedence. Division, say suppose 5, division has the next higher precedence. 4, multiplication has 3, addition 2 and subtraction 1. And we have given a operator left bracket as a priority 0 which is there. Now Bodmer's rule also is to be followed. Now what we do is that there is a conversion rule given in your book. Try to find this rule. You have to first push a left bracket into the stack and a right bracket at the end of the expression. Okay, x is your arithmetic expression which you want to convert. So here this is your x, this is the expression which you want to convert it into postfix. Okay, and so you will, first step is that you have to add a left bracket into the stack and a right bracket at the end of the expression. Now scan, you have to scan all the elements from right to left, from to scan each and every element of these x. These are the elements of the x which will be going to be scanned one by one, and we have to perform some operations according to the type of operand. That is, if the operand is if the element is we have to according to the type of element. If the element is operator, we will, what we have to do, if the operator is operand, then what we have to do, if the operator is a left bracket, then what we do, if the operator is a right bracket, then what we have to do. So we will start with the this process and repeat it. First, if an operator is if an operand is encountered, add it to y. So y is my final postfix expression. See, first operand is a is a operand, first element is a, if the operand is encountered, I have to simply add it to y. So what I have done is that I have added a to this expression y. Then plus is a bracket. Now plus is a operator. Now try to compare this operator with the priority of the already inserted element. Now left is already inserted there. If the priority of the plus is less than the element whose priority is more than the element to be added, now the left bracket has a less priority, so we can simply add to the stack. So plus is added to the stack. Then we have left bracket, again left bracket is there, so we have put the left bracket here also. Okay, so we have put the left bracket here also. Then we have b is a operator, b is operand, it is pushed into the y. Then star, now star is a operator, star operator is a precedence more than the bracket left, so it is pushed into the stack, it is pushed into the stack. c c is a C is a operator, C is operand, so it is pushed into the expression y. Minus is a operator, okay, but minus has less priority than multiplication, so we have to remove the multiplication from here and add it to the expression. Next we have to check the minus with the bracket has less, so we can now stop here and add the left multiplication my subtraction operator to the stack. Again, next is left bracket is directly pushed into the stack. D is the operand, it is directly added to the expression y. Now the division has a more priority than this, so it is added it to the stack smoothly. E is the operand, it is smoothly added. Then caret sign, now caret sign has the more priority than the division, so it is added. F is the operand, it is directly added to this right bracket. Whenever right bracket is encountered, you have to pop up all the elements from the stack, and that is, or pop up all the operators from the stack, and you have to add them to the expression y one by one. Here caret sign, exponential sign is removed and added, plus this division sign is also removed and added. This left bracket is also removed, but it will not be going to add it. So you have to remove all the operators from the stack till a left bracket is encountered, and there you have to stop. After that you have to stop, and all the elements except the left bracket will be pushed into the expression y. Again, multiplication is there, it has priority more than the minus, so it will be added. Then is your right bracket. Again, right bracket is encountered, so you have to remove all the elements. This star and minus will be popped up from the stack and added to the expression, and this bracket is also removed, but it will not going to be add. Then we have h is added to here, and then we have a right bracket. Now this right bracket is matching with the first bracket which we have inserted in the beginning deliberately. So it popped during the stack, and we have our work is this expression is working fine. So this is how we can have a algorithm which can convert any infix expression to postfix expression using stack. Try to do this try to learn this arithmetic algorithm with some other more examples, and then you have to find out the answer. Okay, let us perform one more example which help us to understand this process. Suppose this is your expression which you want to convert into postfix. Let it call be x into the stack and a right bracket at the end of the x. Now scan the each and every element one by one and find the answer. First, there is left bracket is encountered, push into the stack. If A is encountered, push it into the Y. If plus is encountered, push it into the stack. Okay. Then B is encountered, push it into the expression Y. A left bracket is encountered, pop all the elements if left bracket is encountered, and pop off, and popping all the elements, add them into the expression Y. Now again a multiplication, push it into the stack. C is the operand, push it into the expression Y. Slash is the and pop all the elements and push it into the expression Y. This is how you get the postfix expression. I hope you have understood this method. Try to use this method with the various examples given in your book and understand this method clearly. Okay, there is one more algorithm using which you can evaluate any postfix expression using stack. Let us try that also. For example, I want to evaluate a postfix conversion. There is a postfix conversion given to me, and I want to find out this answer. What I have to do is that I have to scan the each and every element and perform the actions. Okay, so for example, let me show you 4. If 4 is encountered, is push 4 into the stack. Then 10. 10 is an element, push it into the stack. The stack will have 4 and then above on it 10. Now push 5 into the stack. So whenever your operands are encountered, you have to push them simply into the stack. But when operator is encountered, for example here plus is encountered, you have to immediately pop up the last two elements from your stack and perform the operation in the elements were added. It means if I have added A and B, so elements will be A is added, then B is added. So when pop up, B will be popped up first and A. So you have to perform the action just the way required. Okay. Again, if you get the intermediate result, push it into the stack. Now star means again pop the last two elements from the stack. This time you will pop up 15 and 4, multiply them, and you will get the answer 60. Pushed it into the stack. Then 15, push it into the stack. 3, push it into the stack. Division, again pop the last two elements, that is 15 and 3. So divide the 15 by 3 and you will get the answer 5. Push it into the stack. Again minus is there, perform the operation 60 minus 5 and you will get 55, and then push it into the stack. Now finally end of the expression is done, so you have to pop the final result 55 from the answer. So this is how you can perform the evaluation. You can also evaluate an logical expression where false, true, not, or are there. So scan the elements. First F means false, Q means push to the stack. Not is the operator. Now you have to apply the not on the T. If it is true, not applied on the T. Now if it is false is equal to true, result will be true. The false result is pushed into the stack. So we have into the stack F comma F. Then or means you have to pop up the last two elements, and the pop last two elements means false and false. So F or F will give again a answer F, so I will push the F into the stack and continue. Then again push is to T, then T is pushed into the stack, F is pushed into the stack, and pop the last two, that is the true and next is or, pop the two elements F or F, the answer is again F, push it into the stack. Then you have AND means pop all the elements and F is the result which is popped out. So this is how you can perform the various arithmetic operations in a stack. I hope you have understood all the arithmetic operations. If you have any problems you can ask me. Now in the next video we are going to discuss about the query, about the queues and how they are implemented using list and what are its queue types. Thank you.